Right now, somewhere in your organization, an AI copilot is answering a question with data from a table that was deprecated 6 months ago. The answer looks perfect, the SQL is clean, the number is precise, and it is wrong. Not because the model failed, but because no one told the model what your organization actually knows about that table. You're spending millions making AI smarter and data cleaner. And the thing that will actually determine whether enterprise AI works for you is something almost no one is building: infrastructure for the gap between data and meaning. That's what we need to talk about. We've watched this pattern play out at organization after organization. The AI pilot works in the demo, it works in the sandbox, then it hits production, where there are 5 tables that could answer the same question, 3 different definitions of customer, and no machine-readable way to know which one the CFO trusts. The gap between a working prototype and a trustworthy system is not a model problem, it's a context problem, and most teams aren't treating it as infrastructure. The dominant playbook for enterprise AI readiness runs on 2 tracks. Track 1, improve the data, modernize the warehouse, adopt lakehouse architecture, invest in data quality, clean the pipelines. Track 2, improve the models, fine-tune LLMs, build RAG architectures, deploy AI agents, iterate on prompts. The assumption, sometimes stated, more often implicit, is that if the data is clean enough and the model is capable enough, the distance between them closes on its own. Context, business definitions, lineage, who owns what, governance policies, is understood as metadata, something teams document in a catalog or a wiki for human consumption, not something that constitutes infrastructure in its own right. This view has real merit. Modern LLMs are remarkably good at inferring meaning from column names, table structures, and sample data. RAG architectures pull supplementary information at query time, and the enterprise technology graveyard is full of middleware layers that added complexity without proportionate value. Practitioners have earned their skepticism toward anything that sounds like add another layer. The conventional wisdom says invest in data quality, invest in model capability, and context will emerge as a byproduct. There's a further argument that makes this view even more reasonable. Cloud platforms and BI tools have embedded semantic layers that appear to handle context within existing tools. dbt metrics layer defines calculations. Looker's modeling layer encodes business logic. Databricks Unity Catalog stores table descriptions and tags. Why build a separate context layer when each tool in the stack already carries some context? The answer is because some context distributed across 12 tools is not context at all, not for a machine. The conventional approach breaks down at a specific moment, when the consumer of data shifts from a human to a machine. A human analyst navigating a data estate carries institutional knowledge in their head. They know that the ARR monthly column was deprecated in Q3 2023 in favor of MRR normalized. They know that the finance team considers only the latter authoritative for board reporting. They know the delta between the 2 columns traces back to a change in how free trials were counted. They know 3 dashboards still point to the old column because the migration stalled. None of this knowledge exists in the data itself. It is not a data quality issue. Both columns contain valid numbers. It is institutional knowledge, and the analyst has it because they were in the Slack thread, attended the meeting, or learned it from a colleague. An AI agent has none of this. When a text-to-SQL copilot encounters a question like, what is our monthly recurring revenue by region? It needs to resolve a chain of context decisions. Which table is authoritative? What does region mean here? Sales territory, legal entity geography, or customer billing address? Which filters are standard? Whose metric definition governs this? In the conventional setup, the metric definition lives in dbt, the ownership lives in the catalog, the trust signal lives in someone's memory, the lineage lives in the transformation layer, and the business interpretation lives in a Confluence page last updated 18 months ago. The AI system can't assemble all of this, and the failure isn't a graceful degradation, a blank screen, an error message, or a request for clarification. The failure is a confident, well-formed, precisely wrong answer. The SQL is syntactically correct. The table is real. The number is specific. And it is built on a deprecated source that no machine-readable signal identified as deprecated. It gets worse as the environment scales, though. In a 50-table environment, a capable model can often infer enough to get it right. In a 50,000-table environment with 400 dashboards, 12 teams, and 5 years of accumulated definitional drift, inference is not a strategy. It's a lottery. There is a second failure mode that is structural, not probabilistic. Embedded semantic layers, DBT metrics, looker models, Unity catalog tags, were designed for a specific consumer, a human analyst or a BI dashboard. They encode a narrow band of context optimized for SQL generation and visualization. But an AI system operating across an enterprise needs a fundamentally broader context surface. Who owns this data? When was it last validated? What downstream systems depend on it? What is the sensitivity classification? What governance policies constrain its use? How does this metric relate to adjacent metrics? What changed last week? Embedded layers answer, what does this calculate? They do not answer, should I trust this column? Who says so? And what happens if I use it wrong? And there is a third failure mode that may be the most consequential. In the pre-AI paradigm, governance could be retrospective. A human wrote a query, built a dashboard, and a steward could review it before it reached stakeholders. The pace of consumption allowed human-in-the-loop validation. AI inverts this entirely. When an AI agent generates and executes hundreds of queries per hour, serves answers to business users in real time, and chains outputs into downstream automations, there is no moment for a human to intervene. Governance must be embedded in the context that AI consults before it acts, not applied as a review after. Without governance signals that machines can read at runtime, enterprises face a binary choice. Slow down AI to human speed and lose the value, or let AI operate ungoverned and accept a level of risk no organization can actually quantify. Neither is viable. The reason most enterprise AI initiatives stall is not data quality or model capability. It's that the AI systems have no way to access what the organization knows about its own data. The enterprises that succeed with AI are those that are building a context layer, infrastructure that makes institutional knowledge, trust, meaning, ownership, lineage, governance, machine-readable and available to AI at the moment of a decision. A context layer is not a catalog. It is not documentation. It is not a semantic layer inside of a BI tool. It is a dedicated infrastructure tier that sits between the data estate and the systems that consume it, human and machine alike, and provides structured, queryable, real-time answers to the questions AI systems cannot answer from the data alone, like who owns this data? Is it certified? What does this term mean in the business unit? What policies govern this dataset's use? What changed since yesterday? What downstream reports break if this table is modified? The mechanism is simple to state, but it's hard to build. Take institutional knowledge that currently lives in human heads, Slack threads, Confluence pages, and tribal memory, and try encoding it into a structured format that a machine can query at inference time with the same reliability that it queries database tables. This is not adding middleware for the sake of architecture. It is recognizing that AI systems are a fundamentally different class of data consumer, one that can't attend the meeting, read the Slack thread, or ask the senior analyst what region actually means. If we want AI to operate with the judgment of an informed practitioner, we have to give it what an informed practitioner has: context. The trade-off is real. Building a context layer requires sustained investment in making implicit knowledge explicit. It requires data teams to treat metadata not as documentation overhead, but as operational infrastructure, maintained with the same discipline as production pipelines. It requires governance teams to shift from writing policies humans read to encoding policies machines execute. This is cultural and operational change, not just a technology purchase. Organizations that treat a context layer as a tool deployment rather than an operating model shift will build another piece of shelfware. But the asymmetry is decisive. Two organizations with identical models and identical raw data will produce dramatically different AI outcomes if one has a context layer and the other does not. The context layer is what turns a capable model into a trustworthy system. And because institutional knowledge is proprietary and accumulates over time, unlike models, which commoditize, and raw data, which is increasingly available, the context layer represents a durable competitive advantage. The longer an organization encodes its institutional knowledge, the wider the gap between its AI capability and its competitors. Now, three patterns validate this reframe, each drawn from a different angle. First, the trajectory of RAG itself tells the story. Retrieval augmented generation exists because the industry recognized that models cannot rely on training data alone. They need external context at inference time. But most RAG implementations retrieve documents, PDFs, wiki pages, knowledge base articles. They treat context as unstructured data or text, documents to be broken up, converted to vectors, and retrieved by similarity. The context layer is the logical extension of RAG's own premise. If AI needs external context, that context should be structured, machine-readable, and real-time, not a search over stale documents. The organizations pushing the frontier are moving from retrieve a document to query a structured map of everything we know about our data. This is not speculation. It is the observable direction of every serious enterprise AI architecture. Second, every major data platform vendor has started building fragments of a context layer, which validates the need while demonstrating the problem. dbt semantic layer, Databricks Unity Catalog, Snowflake Horizon, Google Dataplex, each covers one slice of context within one platform. But enterprises don't operate within one platform. They run Snowflake and dbt and Looker and Fivetran and Airflow and a dozen other tools. A context layer that only knows about one platform's metadata is not a context layer. It's a silo with better branding. The need for a cross-platform, tool-agnostic context layer is precisely what this fragmentation reveals. Third, there are systems purpose-built for this function. Atlan's architecture represents one concrete implementation of the context layer concept. Atlan aggregates metadata, lineage, ownership, quality signals, governance policies, and business definitions from across the data stack into a unified active metadata layer. Atlan's active metadata approach means the context updates as the data estate changes, so the information AI consumes reflects the current state, not a stale snapshot. Atlan exposes this context programmatically via APIs and MPCs, making it queryable by AI systems at inference time, not just browsable by humans in a UI. Atlan's governance capabilities, classifications, policies, access controls, certification statuses, travel with the metadata, meaning an AI system can check, am I allowed to use this data, and is this data certified, before generating an answer, without requiring a human reviewer. What matters here is not the specific tool, but what the tool demonstrates. The context layer is not theoretical. It is operational. Organizations are already running it, and the difference between their AI systems and those without a context layer is the difference between a system that a business trusts and a system that stays in the sandbox. Now, if this is correct, several things change for data teams. First, AI readiness assessments need a new dimension. Most organizations evaluate AI readiness along two dimensions: data infrastructure maturity and model capability. The context layer adds a third: context infrastructure maturity. A team with a modern warehouse, clean pipelines, and a state-of-the-art model, but no machine-readable context layer, is not AI ready. They are demo ready. Production readiness requires that an AI agent can programmatically determine which table is authoritative, who owns it, what it means, and what policies govern its use. Second, the role of data governance shifts from compliance function to AI enablement function. In the context layer model, governance is not the team that slows things down. It's the team that makes AI possible at speed. Every business term defined, every certification issued, every policy encoded becomes machine readable context that directly improves AI output quality. This is a fundamental repositioning from cost center to competitive infrastructure. Third, the metadata team, often an afterthought, becomes as critical as the data engineering team. If institutional knowledge is the raw material of the context layer, the people who capture, structure, and maintain that knowledge are building the infrastructure that differentiates their organization's AI from a generic model running on generic data. So, what do you do with all this? Start with the diagnostic question. This week, ask your team, if an AI agent queried our data state right now, could it determine which table is authoritative? Who owns it? What the key terms mean in your business? What government's policies apply? Not could a human figure out this by asking around, but could a machine resolve it via an API call? If the answer is no, the organization does not have a context layer, and every AI initiative is operating on borrowed confidence. Then make one decision. Treat metadata as operational infrastructure, not as documentation. This means maintaining it with the same discipline, the same SLAs, and the same accountability as a data production pipeline. If a pipeline breaks, someone gets paged. If a business definition goes stale or an ownership record is wrong, the same urgency should apply. Because in an AI-driven organization, stale metadata produces wrong answers at machine speed. The longer path is a sustained program of encoding institutional knowledge into machine-readable formats. Business definitions in a structured glossary, certification status on critical data sets, governance policies expressed as rules, not as paragraphs in a PDF, ownership and lineage maintained automatically, not manually. This is not a 6-week project. It is an operating model change. But every piece of institutional knowledge encoded is a permanent improvement to every AI system that consumes it. The compound effect is the point. Organizations that start now build an advantage that widens with every month of accumulated context. The constraint on enterprise AI is not intelligence, it's context. The organizations that make their institutional knowledge machine readable will build AI systems that the business trusts. The ones that don't will keep rebuilding the same demo. But this raises a harder question. What does it actually take to encode institutional knowledge at scale? And where do most teams actually get stuck? That's what we'll get into next.